first and foremost, a big congratulations to all the parents and teachers. They have played an immense role. Even though the students came here and I was giving them trophies, back of my mind I was only thinking about the parents who have made it all possible. A big round of applause for all of you, all the parents and teachers. The students will understand it later. The children will only understand it later about what you have done to them. If I have to remember in my life, I remember two scientists very closely. I am basically a scientist at heart, even though I am sitting as principal of Goa College of Engineering. My journey has been mostly to do with science, and I did a lot of scientific work when I went to US. And we were working in the area of nanotechnology. Never ever had I seen microscopes of that size. When I landed up in the US and started seeing things at nano scale, and it was in 1995 when we started working at nano scale. Nano means 10 to the power of 9. Many of the students, I go to my class and ask, what is the diameter of the human hair? Many would not know, and that is where we start. The mathematics, applied mathematics starts kind of there. A typical human hair is about 60 microns, and you should be able to see it. So ordinary eye is able to see 60 microns or maybe 50 microns. Or if your eye is even good, perhaps you can even see 30 microns. So we can see up to micron level, but beyond microns, you of course definitely need a microscope. But then you have to do at a nano scale, 10 to the power of minus 9, and again you need a very high resolution. What I saw is when you see through these high resolution microscope, you can even today we have microscopes which can look at atoms, you can even look at, okay, this is the nucleus, this is where the likely position of the electrons are. Technology has gone that far. I mean, the Japanese are moving very fast ahead and they have done it. So what my request to all my young Vedic mathematicians here is, mathematics, pure mathematics is one side, which is going to be highly appreciated. You will be very much in demand. If you have passion only to do maths, like you want to become a Ramanujan, it is still possible even in today's world. I also have a lot of respect and regard for that wonderful man who existed about 80 years ago. I mean, I don't know how many of you, I think perhaps that should be one of the chapters, or maybe you can play a video of what Ramanujan did in those days, and why he is even today regarded as one of the best mathematicians in the world. Please read about him, and there are some YouTube videos also you will know about him. So he is a great inspiration. And then comes, of course, I did not become a mathematician, so I have not followed him. I went after C.V. Raman, and C.V. Raman is another great scientist India has produced. And if you see, he is the only one who has till today got a Nobel Prize. Nobody else till today has got a Nobel Prize. And his the Nobel Prize equipment just costed 500 rupees to make. For just 500 rupees. And then he sat in Calcutta, he was doing some experiment, then he saw, okay, this is how refraction of light happens, and this is how the things go up. He then comes back and then he told Rutherford, see, I have found that there is some portion which is not coming back. And that is where my role comes in. So I will not go into the physics of Raman's effect, but mathematicians and physics, mathematicians and chemists, mathematicians and biologists, you have to work together to solve the problems of the future. There is many things that we have still not discovered. So one of the classes that I also take for my students is, what is the difference between discovery, innovation and creativity? Many people get confused when we ask this question. What is discovery, innovation and creativity? So discovery is something that already exists. Right? So there is something we need to discover. And perhaps many of us don't know that C.V. Raman and Subramanian Chandrasekhar, who also got Nobel Prize, but he was an American citizen, is a nephew of C.V. Raman. So C.V. Raman, what his nephew did exactly was to follow the path of C.V. Raman, but he got into astrophysics and got into deep space studies, and he was looking at how the stars are formed, and he got a Nobel Prize for discovering something related to the stars. So they all started off, if you read their life histories, you will see that their trajectories, they begin somewhere with math and physics, and then further intensify. So all of you are in the right platform, and thanks to Sagar sir, he has given you that platform. I would request all the parents and students, please accelerate now. I mean, we have very little time because time passes very fast. So you guys have to work overtime, and then you will pick up. And once you pick up, and that day and night, if you see that Ramanujan, if you read his history, he never slept. Day or night, he was only solving problems, solving problems. So some of you, I am hopeful that with this spark in your, brain, will definitely, some of you will become some great scientists. May not be as great, I don't mind, but you will definitely contribute because the spark is already lit, and that spark will definitely become a flame, and that flame will ensure that you people will lead the way for this country. So I am very proud that you guys have taken the initiative and done a great service to this field. Second most important scientist that I always think of, and I would request all of you to study the life, is J.C. Bose. Many of us don't know J.C. Bose. He also studied in Cambridge. But we all study electromagnetic waves. We all study electromagnetic waves. We write down in the physics class. There is so many hertz. There is so many hertz. Hertz and our J.C. Bose were classmates. Both of them have worked on that. It's only that Hertz were continued to stay in the UK, and therefore you hear his name. But J.C. Bose comes back to India to serve his country, and then he works free. You know, the conditions of that, conditions of India was such that the British were still ruling. Because the British were still ruling, they did not accept an Indian professor to teach in the college. So this was Presidency College. But professor said, in any case, I will teach freely. So he started teaching the students freely. The response of the students was so good that the management then said, it was the British management who finally said, no, we'll start paying you. So they had to come back and tell J.C. Bose, we will pay you. Even today, if you visit Kolkata, please make it a point to visit his institute. His institute is one of the highly respected institutes in India. Again, if you see his apparatus, it may not be costing 1,000 rupees or 1,500 rupees if you see, but he proved what even before Tesla could do, he had done it. So that is the power of this Vedic mathematics. Vedic mathematics, what we are all understanding today, is something that has come to us over the generations. And we are very fortunate that at least we have now realized the treasure. We did not sleep for some more years. If we have slept for some more years, perhaps we would have lost something even more. So we have woken up, we have opened the doors. We call it as Vedic mathematics, but Vedas, and then subsequently it is somehow been preserved by the subsequent various kings who make sure that Varaha Mira, if you look at his life, he went all the way up to Turkey and even beyond Turkey, and he used to travel. Look at that man. I think many of you would have studied about Varaha Mira. That is, I think, part of the Vedic culture for us. And all the astrology, astronomy that we talk about, going through all the houses of astrological charts, is all something that he was able to visualize. I mean, they were all able to visualize the constellations, the stars, everything, and they would put, okay, this is the place, position, and they are located. We did not have any telescopes, but it was later verified that what these rishis have said are relevant even today. So there is another parallel path, which is this is only for perhaps those who understand the deeper essence of life, that is the conscious, the subconscious, and superconscious mind. So we have something that is stored in the subconscious, conscious, and superconscious mind, which through deep introspection they were able to use it to convert it into something tangible. So there is a lot of science in this also. So I would hope that some of us explore into these domains, including that domains of the mandalas and the architecture that we all talk about. There is a lot of science that is even today hidden. Why Mangeshi temple is a certain way, why power is absorbed in certain temples and churches and places of worship, what really happens, the electromagnetic energy that is stored in all these places. These are something that has to be resolved. We have still not understood ourselves. We don't understand the human body. What happens to the prana when it leaves the human body? Nobody knows. So there are many such things which are still to be understood. So mathematics has a primary role to play in understanding the working of the universe, I should say. So please keep yourself open-minded. Go into the depths of understanding. You have to dive deep. What sir has taught you is just the tools and techniques. Now you have to go into the application level. It's a journey that has to start. And the journey will never end. I am 150% sure, take my word, this journey will never end. And it will go on, it will go on, and it will go on. And you, the rest of your life will be part and parcel of this wonderful journey. So keep that spirit and keep working on it. And I bless all of you guys that the Supreme Being, the consciousness, may it shower the best of the best so that you are unraveling the mysteries of this universe for the rest of the world. Thank you.